from 90 degrees centigrade to 80 degrees centigrade in T minutes when the room temperature is 20 degrees centigrade. So this is a question from Newton's law of cooling. So for any body which is radiating heat, so this is the temperature of the body. T naught is the surrounding temperature. Okay, and E sigma and A is the surface area, and sigma the Stefan-Boltzmann constant, and E is the emissivity. So the radiating heat per second is this formula. Okay, now when T and T naught are very close by, okay, so in this case we see what is the T is, okay, for the first case, okay, so the temperature is on an average 85 degrees centigrade, which is 273 plus 85, which is 358 Kelvin, and T naught is 273 plus 20, which is 293 Kelvin. So almost 1/6 is the change. So kind of we can approximate it to be almost same, and also the delta T, the temperature change, is just 10 degrees centigrade, which is also less. So in such cases what we do is we approximate this formula using binomial theorem, using taking T as T naught plus delta T, and then the formula becomes this. So delta U is equal to 4E sigma A T naught to the power 3 to T minus T naught, where T is again the temperature of the body, T naught is the surrounding temperature. Now this much heat is being lost, and the temperature is going to decrease now because heat is being lost from the body. Now how the temperature is going to decrease, like what formula we should use? So therefore we have this specific heat capacity. So M into S, this is the, so like in delta T time, the heat lost is going to be delta U into dt, which causes the decrement in the temperature. Okay, so how much decrement in temperature? Ms dt. Okay, so now combining all of that, this is the equation which we get. So dt by dt, that is the decrease, the rate of decrease of temperature, rate of decrease of temperature is equal to minus B into A into T minus T naught. Now let us do this question. So for the first case we have dt by T. Okay, so dt is the temperature change is going to be 10 degrees centigrade divided by T is equal to minus B into A T minus T naught. So T here will be taken as the temperature of the body, will be taken as the average temperature. Okay, so in the first case, what is the average temperature? 80 plus 90 divided by 2, which is 85 degree centigrade. Okay, so we have 85 minus, or like actually we should take in Kelvin. So but in Kelvin also it's going to be 85 plus 273, and this is minus 20 plus 273. Okay, so this becomes 273 is gone. So minus BA into 65. That's the first equation. For the second equation, we have how much decrement is happening? 80 minus 60, that is 20. So 20 degrees centigrade divided by T1. This should be equal to minus B into A. Now what's the average? Average is 70 degrees centigrade here. So 70 degrees centigrade minus 20, this becomes 50. So now we divide the first equation by the second equation. So 10 by T into T1 by 20 is equal to 65 by 50. Gone. So 2, so this is gone, as this becomes 25. 5, so this is 13 by 5. So therefore T1 becomes 13 by 5 into T. So this is going to be the answer. Okay, I'll quickly summarize again. This is done based upon the concept of Newton's law of cooling. In Newton's law of cooling, if suppose we have to just remember the one formula, just remember this: dt by dt is equal to minus BA T minus T naught. Okay, so this d capital T by dt is the rate of change of temperature. Okay, and this is only applied when the temperature is close to room temperature, not like 1000 or 2000 degrees. Then this formula will not work. Then we have to use the original formula. So this is an approximation formula when T and T naught don't have that much difference. And this is equal to B, which is a constant, A is the surface area, T minus T naught. T is the temperature of the body, T naught is the surrounding temperature. Thank you. So therefore the answer is going to be C.